Now let us talk about the real case when a load resistor is connected across the diode as shown in the figure on your screen. The capacitor will charge up, but a net DC current must flow in R. Since at this time the diode is off, this current obviously comes from the capacitor, thus causing the capacitor to discharge and the output voltage to fall. Let's see that graphically. During the interval T0 to T1, the output voltage falls exponentially with time constant CR. At T1, the input decreases by VA volts and the output attempts to follow. This causes the diode to conduct heavily and to quickly charge the capacitor. At the end of the interval T1 to T2, the output voltage would normally be a few tenths of a volt negative, that is minus 0.5 volts. Then as the input rises by VA volts at T2, the output follows and the cycle repeats itself. In the steady state, the charge lost by the capacitor during the interval T0 to T1 is recovered during the interval T1 to T2. This charge equilibrium enables us to calculate the average diode current as well as the details of the output waveform. However, we will not go into that detail now.